Hello and welcome to this session on information systems in business today, where we'll be discussing about the emerging trends in IT. Because of the recent developments in hardware, software, and the information systems designs, today we have various interesting trends that are coming up, which are being embraced by managers in order to carry out business processes and to make profits. The various emerging trends in information technology that is embraced by information system specialists are some of the notable ones are e-commerce, artificial intelligence, expert systems, machine learning, deep learning, last but not the least, analytics. So this has brought about a paradigm shift in the way we used to do our work using information technology and information systems. First, we'll start with the most popular emerging trends in IT, which is e-commerce, followed by we'll be having a discussion on artificial intelligence, then slowly make a shift towards machine learning by understanding expert systems. This is what we are going to discuss in today's session. E-commerce is one of the most interesting trends that you find in information technology arena today. It is nothing but the use of internet and web to make business transactions. It began in, although it had an early beginning, but we can say that it began in 1995 and grew exponentially, and it remained a stable trend even during recession times. Companies that survived the dot-com bubble during this era have been thriving today because of its usefulness and user friendliness. E-commerce today is so popular that it has given rise to many other trends like social media, mobile commerce, etc. This graph basically shows how retail e-commerce revenues grew from 15-25% per year until the recession of 2008-2009, when they slowed measurably. But again, in 2014, e-commerce revenues started growing again at an estimated 12% annually, and it has been on the rise today. Some of the unique features of e-commerce can be described by these 8 unique features of internet and web, which is being used as a commercial medium. The 8 unique features of the internet and the web which characterize e-commerce are ubiquity, global reach, universal standards, richness, interactivity, density, personalization or customization, and social technology. We'll be discussing each one of these one by one to understand how e-commerce, this emerging trend of IT, has become so popular because of these features. Ubiquity is the aspect that has revolutionized e-commerce. Internet or web technology is today available everywhere, may it be in work, home, or any place, anytime, anywhere. So if you take the effect of e-commerce and this feature of ubiquity, you find that the marketplace has been removed from temporal geographic locations to become a market space. Because of e-commerce, today we don't talk about marketplaces, rather we talk about market spaces. E-commerce has enhanced customer convenience and reduced shopping costs. If you take a look at what effect ubiquity, the feature of e-commerce, has on us, one important aspect that you can note is that it reduces transaction costs. That is the cost of participating in market. E-commerce has a global reach. Today, earlier people were selling in the local markets and were unable to sell their products around the world. Because of e-commerce, because of internet and web penetration throughout the world, the global reach has spread for people buying and selling via the web. Uh, this technology today reaches across national boundaries around the earth. And if you measure the effect of this feature, you'll see that commerce enabled across cultural and national boundaries seamlessly has been happening and without modification. And you'll see that as we made a shift from marketplace to market space, the market space includes potentially billions of consumers and millions of businesses worldwide, improving dramatically the profit of business people. E-commerce is popular because it follows universal standards. That is one set of technology standards, which we can call as the internet standards. And this feature has impacted our lives in a way that dice separate computer systems easily can communicate with one another today. There is a lower market entry cost, that is, cost merchants must pay to bring goods to market. There has been a lower consumer's search cost. That means effort required to find suitable products has become lower. E-commerce supports video, audio, and text messages. So the richness is one of the features of e-commerce. It provides richness and it has an effect. That is, it is possible to deliver rich messages with text, audio, and video simultaneously to large numbers of people today. Video, audio, and text marketing messages can be today integrated easily and seamlessly into single marketing message and consumer experience. The fourth feature, which is interactivity. E-commerce uses internet and web technology and works through interaction with the user. So it has a great impact or effect on the users. Consumers today can get engaged in dialogue that dynamically adjusts experience to the individual. And consumer becomes co-participant in process of delivering goods to market. The next feature is information density. E-commerce, when you use, it provides information density. That means it has largely increased information density. That is, the total amount and quality of information available to all market participants is very high. And it has an impact. Impact on what? Greater price transparency is possible today. There has been a greater cost transparency, and it because of information density, e-commerce enables merchants to engage in price discrimination. E-commerce has led to customization or personalization. What does that mean? That means e-commerce technology permits modification of messages and goods. Personalized messages can be sent to individuals as well as groups. This is one of the effects of the customization feature of e-commerce. products and services can be customized to individual preferences. Social technology is another feature of e-commerce. E-commerce technology promotes user content generation and social networking. New internet social and business models enable user content creation and distribution and support social networks. And it enables a many-to-many model for doing business. Effect of the internet on the marketplace can be seen as a result of heavy use of e-commerce. E-commerce reduces information asymmetry. It offers greater flexibility and efficiency because of reduced search costs and transaction costs, provides lower menu costs, provides greater price discrimination, and enables dynamic pricing. It can also reduce or increase switching costs. It may delay gratification, and it can have effects, great effects on dependent, the effects of effects which will be dependent on the product. It also provides increased market segmentation, and also it enables stronger network effects and more disintermediation. Disintermediation is one of the greatest features which has made the IT popular. From the producer to the customer, disintermediation has created a nice bondage between the producer and the consumer by removing intermediaries from the value chain or the supply chain. You can see how the cost per sweater has decreased because of disintermediation. Earlier in the first chain, you see the cost per sweater was $48.50, but slowly when we had disintermediation as a result of use of internet and web, like we removed several intermediary layers, and it drastically or dramatically reduced cost of a sweater. So this particular diagram shows the typical distribution channel which earlier had several intermediary layers, each of which added to the final cost of a product. But removing the layers also lowers the final cost to the consumer. So e-commerce has benefited consumers to a large extent. As a result of e-commerce, we are coming up with digital goods, that is goods that can be delivered over a digital network, like music tracks, videos, softwares, newspapers, books can today be easily be delivered to the consumer. Cost of producing first unit is almost entire cost of the product. Cost of delivery over the internet is very low. Marketing costs remain the same. Pricing highly becomes variable. And industries with digital goods are undergoing revolutionary changes like publishers, record labels, etc. There are three major types of e-commerce. The first one is business to consumer. One good example is barnesandnoble.com. Business to business, Can Connect is an example. Consumer to consumer, eBay is a typical example of C2C. E-commerce can be categorized by platforms. Mobile commerce is one type of e-commerce which is categorized by a platform. There are many business models as a result of e-commerce. The first one is you can come up with a portal, which is a particular type of business model of doing electronic commerce. E-tailer is another. Content provider is another business model. Transaction broker is another business model of e-commerce. Market creator, service provider, community provider are other business models of e-commerce. Many revenue models can also be achieved using e-commerce for advertising, sales, subscription, free, freemium, transaction fee, affiliate. E-commerce helps or supports marketing. Internet provides new ways to identify and communicate with customers. Long tail marketing is possible. That is, ability to reach a large audience inexpensively can be done via the net. Various internet advertising formats can be provided for achieving or reaching the profits that are visualized by organizations. Behavioral targeting can be done, that is, tracking online behavior of individuals of thousands of websites and within apps can be done easily, but it creates privacy concerns. This particular diagram actually shows how e-commerce websites have tools to track a shopper's every step through an online store. If you closely examine customer behavior at a website selling women's clothing, you can see that the store might learn at each step and what actions it could take to increase sales. In this 6 clicks, the shopper or the shopkeeper or the store might learn at each step what to do and what actions it can take to increase its sales. Website personalization is possible today. Firms can create unique personalized web pages that display contents or ads for products or services of special interest to individual users, improving the customer experience and creating additional value. This particular diagram shows how an advertising network works. Advertising networks and their use of tracking programs have become controversial among privacy advocates because of their ability to track individual consumers across the internet. This is a particular concern while advertising via the internet or the web. You can see how the consumer request uh, on a web page from an ad network member site works. It reaches the merchant site, then it goes through the advertising network, and network member forms integrate through the advertising network. And finally, the consumer, when he double click on the sites and goes through from site to site using tracking programs to look for various ads. Social e-commerce is another aspect of e-commerce, which is an emerging trend in the world in the arena of e-commerce. It's based on digital social graphs. Some of the features of social e-commerce, which is driving its growth today, are news feeds, timelines, social sign-ons, collaborative shopping, network notification, and social search. That means recommendations today can be made for a typical search that you have made on the web. Social media is another beautiful emerging trend as a result of heavy use of e-commerce. Social media is one of the fastest growing media for branding and marketing. And social network marketing is today very popular, which seeks to leverage individuals' influence over others in social graphs. Social network marketing targets a social network of people sharing interests and advice. The Facebook like button is an example of social network marketing. Social networks have huge audiences. Like if you take the example of Facebook, there are 137 million US visitors monthly. Social shopping sites, wisdom of crowds, crowdsourcing. That means large numbers of people can today make better decisions about topics and products than a single person when they assemble on the web. Prediction markets are popular because it's a peer-to-peer betting markets on specific outcomes, may it be elections, sales figures, designs for new products, etc. B2B e-commerce. A survey was made on B2B in the US. Uh, 2014 figures shows that it's at 13.8 trillion in the US. Uh, B2B e-commerce in the US in 2014 grew to 5.7 trillion. B2B e-commerce procurement requires significant overhead costs, which internet and networking helps to automate. Slowly, it's picking up in India also. Variety of internet-enabled technologies are used with B2B, like electronic data interchange is one of the most popular variety of B2B, private industrial networks, net marketplaces, and exchanges. But two of these varieties are very popular, electronic data interchange and exchanges. Electronic data interchange is nothing but computer to computer exchange of standard transactions such as invoices, purchase orders. Major industries today have implemented EDI standards that define structure and information fields of electronic documents. More companies are increasingly moving towards private networks that allow them to link to a wider variety of firms than electronic data interchange allows and shares a wide range of information in a single system. This shows how electronic data interchange works. Companies use EDI to automate transactions for B2B e-commerce and continuous inventory replenishment. Suppliers can automatically send data about shipments to purchasing firms. The purchasing firms can use EDI to provide production and inventory requirements and payment data to suppliers. So this is how continuously replenishment can be made by firms with suppliers and vice versa. Mobile commerce is one of the applications of e-commerce, a variety of e-commerce that is growing and becoming popular day by day. In a survey in 2014, it was found out that 19% of all key e-commerce was m-commerce. It's one of the fastest growing form of e-commerce. As you can see, some areas are growing at 50% or more. So, m-commerce is one of the main areas of growth within e-commerce, exclusive of location-based services. Retail sales has been growing at top mobile 400, like Amazon, eBay. Sales of digital content has been happening because of m-commerce, like music, TV. All this is today provided via the mobile through the usage of internet and web. This particular graph shows how mobile e-commerce is the fastest growing type of B2C e-commerce and represents about 19% of all e-commerce uh, in a survey that was done in 2014. M-commerce provides location-based services used by 74% of smartphone owners, which shows the popularity of M-commerce today. It is based on GPS map services, and there are various types of e-commerce. e-commerce like social services, geo advertising, geo information services. If we want to find where friends are, we can use the geosocial services. If we would like to know what shops are nearby, we can use the geo advertising type of e-commerce. If we would like to find out the price of house we are passing, we can use the geo information services of the e-commerce. Other mobile commerce services are banks are making rampant uses of mobile commerce. Credit card companies provide account management applications for m-commerce services. We can carry out display advertising through the mobile. Uh, 55% of online retailers have m-commerce websites today. The most important management challenges that are faced as a result of uses of e-commerce is that developing clear understanding of business objectives is one of the major challenges of e-commerce. Knowing how to choose the right technology to achieve those objectives is another managerial challenge which is faced by managers. To develop a e-commerce presence map is another big challenge for managers. The infrastructure and the architecture has to be in place. The four areas which must be focused to develop an e-commerce presence map is you need to focus on the websites, you need to focus on the email and the protocol to run the email, the social media and the offline media. Another big challenge is to develop a timeline for e-commerce. Various milestones are to be achieved, and it can only be achieved if you handle the e-commerce business as a project. You need to break a project into discrete phases, and you need to stick to the time and the budget to achieve the project objectives. This particular diagram shows how you can build an e-commerce presence. This shows the e-commerce presence map. An e-commerce presence requires firms to consider the four different types of presence like websites, email, social media, or offline media. You need to choose how you want to present yourself. You can present yourself via the websites or through email or through social media or through offline media. And you need to keep track of the activities associated with each of these types of e-commerce presence that you wish to achieve. If you take a look, the first type of e-commerce presence, websites, the platforms that you normally use are traditional or mobile or via the tablets. Activities that can be carried out is you can search, display, use apps, uh, work with affiliates, and be with the sponsors. If you are using a email type of e-commerce presence, you'll be using a platform of internal lists and purchase lists, and the various activities that are carried out through email e-commerce type is you can present or deliver newsletters, updates, and make sales. If your choice is social media, you can present or you can do commerce via the Facebook, Twitter, or blogs. And various activities that can take place on these platforms are conversation, engagement, sharing, and advices. If you are using the offline media, you can use the print or the TV and radio as platforms for education, exposure, and branding. Uh, the timeline that you can follow for e-commerce presence is that you need to go through these 6 phases to achieve these milestones that are shown on the diagram. In the first phase, in order to come up with a e-commerce presence, we need to plan. That means we need to envision web presence, determine the personnel who will carry out the e-commerce activity. The milestones are the web mission statement is to be achieved. The second phase is the website development, wherein the milestone is a website plan, but you need to acquire content, develop a site design, arrange for hosting the site. The third phase is web implementation. You develop keywords and meta tags. You focus on search engine optimization, identify potential sponsors, and what you achieve a functional website. Then slowly, once you have done or gone through these three phases, then you can go or switch to the next phase, which is the social media plan. You can make a social media plan and identify appropriate social platforms and content for your products and services, and deliver your products and services through the social media platforms. Then the next phase, the fifth phase, which is the social media implementation. In order to achieve a functioning social media presence, you need to develop your Facebook, Twitter, and Pinterest presence. Last phase is to come up with a mobile media plan. You need to develop a mobile plan, consider options for porting your website to smartphones. So today, if you have to be successful on e-commerce, probably you have to go through these 6 phases, and you need to stick to this timeline in order to make your presence felt and to conduct business. Next, we'll move on to another emerging trend that we normally use today, and which is very popular emerging trend in the field of IT, is artificial intelligence. This term was coined by John McCarthy in 1956, and the first phase was called as the artificial intelligence winter phase 1. But the journey to understand if machines can truly think started much before that, not just in 1956. Whenever Bush, in his seminal work, As We May Think, proposed a system which amplifies people's own knowledge and understanding. Alan Turing was a pioneer in bringing AI from the realm of philosophical prediction to reality. So Turing wrote a paper, Computing Machinery and Intelligence, on the notion of machines being able to simulate human beings and the ability to do intelligent things. Today, intelligent agents are widely used in machines in order to create intelligence to be used or to take decisions. Turing realized that it would need a greater understanding of human intelligence before machines can be built that can think like humans. And his paper opened the doors to the field to be called artificial intelligence. So Turing's paper, Computing Machinery and Intelligence, defined what would be known as the Turing test, which is a model for measuring intelligence. As I told you, the winter phase 1 of AI was between 1960s to 1970s. In 1960s and 70s, several other experts believed that a machine with general intelligence of a human being was round the corner during the time. But when it did not happen, it resulted in drying up of funds and a decline in research activities on AI. So you had a stalemate till the 1980s. During the 1980s, interest in an approach to AI known as expert systems started gathering momentum. So by 1990s, due to the limited scope of expert systems, interest began to wane out, and this resulted in the second revolution, which is called as the winter phase 2 of artificial intelligence. It appeared that expectations in AI always outpaced the results. So again, research started, and this emerging trend in IT today is embraced by each and everyone in the business world, in the corporate world, in the education world. So a shift from winter phase one of artificial intelligence to winter phase two of artificial intelligence was the expert system. It is nothing but a program that is designed to solve problems in a specific domain, which can replace a human expert. By mimicking the thinking of human experts, the expert system was envisaged to analyze and make decisions. So here in this expert system, rules are widely used. The knowledge base of an expert system contains both factual knowledge and heuristics knowledge. The expert system inference engine was supposed to provide a methodology for reasoning the information present in the knowledge base. So the goal of expert system was to come up with a recommendation, and to do so, it combined the facets of a specific case, the input data, with the knowledge contained in the knowledge base or the rules, resulting in a particular recommendation. So the earlier IT that we normally depended on helped us to make a decision or assist in our decision making. But now we have the tools which can take a decision for the manager. You see, expert system was one such tool which was envisioned in the 1980s. Through an expert system, we were able to solve some well-defined logical problems. It was found out later on that it proved otherwise. In solving other types of complex problems like image classification and NLP, it failed. So as a result, expert systems did not live up to its expectations, and it gave rise to a shift from rule-based approach to a data-driven approach. So this paved the way to a new era in artificial intelligence, which is called as machine learning. So research over the past many years has resulted in significant advances in search algorithms, machine learning algorithms, and in integrating statistical analysis to understand the world at large. So today, these are some of the interesting emerging IT trends that you find and you need to quickly learn in order to do wonderfully well in the business world. You have to make good use of search algorithms. You have to make good use of machine learning algorithms. You have to integrate statistical analysis to understand the world at large. Then only you can forecast, predict, optimize, and do great lot of many other things. So machine learning is a subdomain of artificial intelligence which makes a system automatically discover or learn the statistical structure of the data and to convert those representation or patterns to get closer to the expected output. So the process of learning is improved by a measure of the feedback, which compares the computed output to the expected output. Unlike expert systems, which were done for these latest trends, the machine learning system is not explicitly programmed. It automatically searches for patterns within the hypothesis space and uses the feedback signal to correct those patterns. So to enable a machine learning algorithm to work effectively on real world data, we need to feed the machine a full range of features and possibilities to train on. A typical machine learning workflow includes many of the following, like you need to train the model on a training data set, tuning the model on a development set, and training the model on unseen test data set. You need to try out the above on different but appropriate yet appropriate algorithms using proper performance metrics. You need to select the most appropriate model and then test the model on real world data. If the results are not up to speed, we need to repeat the above by evaluating the data and our model, possibly with different evaluation metrics. Machine learning, uh, we can define data sets which we use in machine learning as follows. Uh, the training set is nothing but the data on which we learn the algorithm. The development set is the data on which we tune the hyperparameters of the model. The test set is the data we use to evaluate the performance of our algorithm. And then we make a good use of the real world set, which is the data on which our selected model will be deployed. So we can define machine learning as the process of teaching computers to learn by automatically extracting knowledge from available data sets. It is synonymous to pattern recognition. Now, learning occupies a prominent place within AI, which broadly encompasses all forms of computer intelligence, both hand-coded and automatically adopted through observed data. There are two major subsets of machine learning. One is called as supervised learning, the other one is called as unsupervised learning. In supervised learning, the goal is to find patterns in available inputs in order to make accurate predictions on new inputs in order to make accurate prediction on new unseen data. For this reason, models used in supervised learning are often called predictive models. I can give you an example. The task of building an automatic spam filter is an example of supervised learning. As a starting point, we can level a small data set of messages by hand. Then a machine learning model is built that discovers what features in the messages are indicative of the message being labeled as spam. The model can be used to automatically classify new messages without manual intervention by the user. Many applications, as given below, can be written as supervised learning tasks. For example, the task to estimate how much a house will sell for based on properties, characteristics such as the number of bedrooms, location, material used, and its size. You can determine whether a mass detected in an MRI scan is malignant or benign. You can predict whether a flight will be delayed given the carrier scheduled departure time, the departure airport, and the arrival airport. You can estimate the number of page views a website will need to handle the next month. Given a picture of a person, you can predict their age and mood. You can predict the increased sales resulting from a new advertisement campaign because of use of supervised learning or the machine learning subtasks. Supervised learning tasks, the domain-specific expertise is essential to the successful construction and deployment of this kind of ML algorithms. However, most methods used for learning a predictive model from pre-processed data consist of applying general purpose training algorithms. The algorithms will learn later on in some course will be applied to a wide range of tasks, including all of the above examples given the availability of sufficiently representative data for training. Supervised learning are those used in classification and prediction. We must have data available in which the value of the outcome of interest is known. Such data are also called label data since they contain the label, outcome value, or for each record. These training data are the data from which the classification or prediction algorithm learns or is trained, but the relationship between the predicator values and the outcome variable should be known. Once the algorithm has learned from the training data, it is then applied to another sample of label data where the outcome is known but initially hidden to see how well it does in comparison to other models. One very good example of supervised learning is the mobile phone customer churn. The fundamental approach in supervised learning is based on training the model and then evaluating its performance. Data are therefore typically segmented into training data, validation data, and test data. Training data for training the decision-making algorithm or model. Validation data to tweak models and compare performance across models. Test data or holdout data to evaluate final model's performance based on new unseen data. So supervised learning, if many different models are being tried out, it is prudent to save a third sample, which also includes known outcomes, that is the test data, to use with the model finally selected to predict how well it will do. The model can then be used to classify or predict the outcome of interest in new cases where the outcome is unknown. One of the best examples of this, where we predict the outcome of interest, is a simple linear regression. It's an example of a supervised learning algorithm. The variable y is the known outcome variable and the x variable is a predicator variable. A regression line can be drawn to minimize the sum of square deviations between the actual y values and the values predicted by this line. The regression line can now be used to predict y values for new values of x for which we do not know the y value. The algorithm is trained to detect patterns that relate inputs and the outcomes. This relation is then used to predict future of new records. An example is predicting the next move in a chess game can be done by using machine learning, using the supervised learning method. The fundamental approach, as I have already told you, is based on training the model and then evaluating its performance. And these three types of data are widely used when you are using the supervised learning method: the training data, the validation data, and the test data. So some of the core ideas in supervised learning are the basic paradigm that is used in supervised learning is classification. It is the most basic form of data analysis. The outcome is called a class and the outcome measurement is a categorical outcome. The best example can be the recipient of an offer can respond or not respond. So a credit card transaction can be normal or fraudulent. Email is a spam mail or not. We can know that. A customer stays or not with us can be found out using supervised learning classification form of data analysis. Prediction is also another type of supervised learning method. It is similar to classification, except that we are trying to predict the value of a numerical variable here. The amount of purchase made is an example, rather than a class, the purchaser or non-purchaser. The outcome measurement is numerical. Unsupervised learning method is another popular machine learning method. Unsupervised learning are those methods which are used where there is no outcome variable to predict or classify. Hence, there is no learning from cases where such an outcome variable is known. Association rule mining or affinity analysis, dimension reduction methods, and clustering techniques are all examples of unsupervised learning methods. One very interesting example is the association or the affinity analysis. This is widely used by organizations for marketing closely related accessories to a particular product. Suppose you are buying a mobile, what are the accessories that will go well with the buy that you made? Association rule analysis can help to predict the accessories for the mobile that you bought. So, few good examples of supervised and unsupervised methods that are sometimes used in conjunction. Uh, Unsupervised clustering methods are used to separate loan applications into several risk level groups. Then supervised algorithms can be used on that separately to each risk level groups for predicting propensity of loan defaults. Unsupervised learning is basically an analysis in which we try to attempt to learn patterns in the data other than predicting an output value of interest. We have a set of measurements for each record. And the purpose is to find relationships either between measurements or records. So, for example, finding different types of customers in terms of their banking history from a banking customer database or customer segmentation is a typical example of unsupervised learning method. Some other core ideas in unsupervised learning are forecasting. It looks at measurements over a period of time to generate future forecasts. As I have already told you, association rule mining deals with what goes with what. Collaborative filtering can be done using unsupervised learning methods. These are nothing but algorithms that search for items that have a large percentage of baskets in common. The idea behind recommender systems is nothing but collaborative filtering. Amazon, Flipkart, these companies widely use collaborative filtering. Cluster, cluster analysis is another core idea of unsupervised learning method, which is widely used in machine learning. It is an automated way of exploring or detecting clusters of similar records. This finally sums up how the data that comes into the organization is used to derive insights by the use of machine learning. First, the first step is the data that comes that need to be prepared. It needs to be explored, prepared, and reduced. Data preparation is the first activity. Data visualization is done, and dimension reduction of the data is done. Then supervised or unsupervised learning methods can be applied onto the data. When we use supervised learning methods, we can do predictions, classifications, and forecasting. When we apply unsupervised learning methods, machine learning methods onto our data, we can do association rule mining, you can do collaborative filtering, you can do cluster analysis or segmentation. But these two methods, once applied, uh, can be applied on to the data, which is fed into a model. The model is evaluated, and a selection of the model is done, where we select the model by evaluating its performance. If the model works well, then the model is deployed, uh, and we derive insights from the model. So basically, there are three levels of understanding that you need to have in order to make good use of the emerging IT tools. First, you need to understand data, prepare your data, reduce its dimensions, clean the data, then apply supervised learning methods or unsupervised learning methods. Uh, then you need to test or evaluate the model and select the appropriate model and deploy the model to benefit out of it. So we have made a paradigm shift because of the emerging IT tools. We have made a paradigm shift from data, handling data, to analyzing data, to generating insights from the data. So today, it's not just e-commerce, machine learning, or artificial intelligence that has been helping managers in organizations. Today, We have been working on a new science that just doesn't have, support analysis or for generating intelligence for business called as business intelligence. It's not just a set of technologies which can generate business intelligence. Business intelligence was widely used till date by organizations to manage data, to analyze data, to integrate data, to transform data, or to generate reports. Today, it is not just business intelligence. We have made a shift from business intelligence as a result of emerging IT tools. We are in a position to derive insights by use of analytical methods. And the science that we'll be talking about or learning in the next session is called as data science, which makes heavy use of data mining, which makes heavy use of analytical algorithms. So the standard database has given way to a thinking database. So we have made a paradigm shift from online transaction processing to online analytical processing to generate or derive insights from the data. We are looking for non-obvious patterns and trends in our data. We are looking for value in the data that comes into the organization and benefit out of it. So with this, we have discussed some of the major emerging trends in IT. We will continue this discussion in our next session tomorrow. Thank you.